Grand Rounds of the year. My name is Dr. Rebecca Muley, and I'm one of the Grand Rounds co-directors, along with Drs. Adi Talati and Alex Harris. Dr. Harris is our online moderator today. Our next Grand Rounds will be on January 22nd, presented by Dr. Carrie Martinowicz, Senior Investigator and Director of Translational Neuroscience at the Lieber Institute for Brain Development and Professor in Psychiatry and Neuroscience at Johns Hopkins University School of Medicine. The talk is titled Cell Type Specific and Spatially Resolved Approaches for Understanding Human Brain Disorders. As a reminder, if you're participating remotely, you may post questions at any time during the talk, but use the Q&A feature, please, not the chat feature. As the online moderator, Dr. Harris will forward questions to me to ask our speaker during the Q&A session. We encourage trainees to consider asking a question. I've already pointed a few of our trainees out in the audience. We always start with our trainee questions, and if you are remote, please do indicate in your question that you are a trainee. It's now my pleasure to introduce today's speaker, Dr. Reuben Robbins, Associate Professor of Clinical Medical Psychology at Columbia University in the Department of Psychiatry and HIV Center, and a Research Scientist Level 6 at NISP. Dr. Robbins is a clinical and neuropsychologist who received his master's at Naropa University in Colorado and subsequently performed his clinical neuropsychology internship at the University of Florida in Gainesville and received his doctorate from Fordham University in 2008. He then joined the Columbia NISP community as an NIMH postdoctoral fellow in behavioral sciences research and HIV infection and came on as faculty in Columbia and NISP in 2011. He became a supervising psychologist at New York Presbyterian Hospital in 2012. He has research and clinical expertise in neurocognitive, mental health, and psychosocial aspects of HIV disease in affected populations, including perinatally HIV-exposed and unaffected individuals across the lifespan, and studies how medical factors and exposure to adversity and social determinants of health affect neurocognition and mental health among vulnerable populations in resource-limited settings. As the PI and co-investigator on multiple NIH-funded grants, he has been at the forefront of developing and testing technology-based clinical tools and interventions for resource-limited and international settings to assess neurocognition and to detect neurocognitive problems among HIV-affected populations, including perinatally HIV-infected adolescents in South Africa, Uganda, and Thailand, as well as HIV-infected adults in the US and South Africa. The title of his talk today is Increasing Accessibility, Accuracy, and Fairness of Neurocognitive Testing for Diverse Global Populations. Please join me in giving him a warm welcome. Thank you,
Dr. Well, thank you for the nice welcome. It's a pleasure and honor to present here at the Grand Rounds today, and actually to finally make it up here to this stage. So today I'm going to talk about the challenges and opportunities of neurocognitive testing with diverse global populations, specifically those in low and middle income countries, where much of my research has taken place. A little closer. Sorry about that. So here are my disclosures. I don't really have, it says I have none, but really I'm the developer of one of the developers of the NeuroScreen app, which I'm going to talk about. But it's not a company. So here are the learning objectives today. Overall, hopefully you'll learn about test validity, how to consider that, and what to think about with tests you might be giving your patients or participants. So I wanted to just start with a little bit of background about myself, how I got here, and how I ended up doing the work that I'm going to be presenting today. So I don't have any cool pictures, so you'll have to bear with me. So I was trained as a clinical psychologist with specialization in clinical neuropsychology, and I've actually been here a long time. I first came to CU NISP as a summer RA working on an NIH-funded study examining the neuropsychological factors associated with returning to work among people living with HIV. That was 2003. I stuck around for 2 years as an extern doing outpatient and medical legal neuropsychological evaluations. I returned in 2008 after completing my APA internship at the University of Florida with a focus on clinical neuropsychology. At that time, I'd do anything to get back to New York from Northern Florida, even sign up for an NIH T32 fellowship that provided a stipend of $35,000 to live and survive in New York City. Now, all kidding aside, and no disrespect to Northern Florida, and I'm having a hard time with my slides here. It's very sensitive, this mouse. Yeah. Well, all kidding aside, I came here to work with Dr. Robert Remian at the HIV Center for Clinical and Behavioral Studies, which was and is one of the longest running P30 center grants from NIH focused on HIV in the country. Bob had recently begun an R34 intervention adaptation project in South Africa and wanted to add some neurocognitive testing. And if I could get into I can't seem to scroll down here. Sorry about this. Well, I'll have to wing it. Anyway, there we go. Make sure I capture everything. So he wanted to include some neurocognitive testing, and I thought that sounds really interesting, and I don't really know anything about doing testing outside of North America. And when I learned I could potentially travel to South Africa, I said, well, let's do this. Although it wasn't my decision. And little did I know at the time that I'd spend most of my career conducting research there and in other low and middle income countries. And all throughout my training and academic life, I've been interested in the issues of test validity and test use among diverse populations. So I recall as an extern years ago doing an evaluation in English with a bilingual German man who couldn't remember some of the English words on a verbal recall test, but was remembering the German word. Now, it just so happens in high school, I had a few semesters of German and knew that the words he was recalling in German were actually the correct words. But I thought, what if I didn't know German? How would I have scored that test? Would I have made him incorrect and his score would look lower and maybe turn out thinking he has some kind of neurocognitive problem? Similarly, I recall this evaluation also as an extern with a Jamaican woman who had never done any testing before. And she was so nervous. In fact, her hands were shaking. And if any of you know the Wisconsin card sorting test, you see these cards, and as the administrator, you can't say anything other than right or wrong. And they have to figure out that pattern. And wrong, 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 wrong. She was losing it. She broke down crying. And she couldn't finish the testing session. And I came out, at the time I was a student. I thought, well, I can't reveal the rule. I tried to console her, but it was just too much for her. And I thought, this is really, must be humiliating to sit here and have to go through that. And I thought, that's not how I want my patients to encounter this experience or have this experience. So we'll come back to some of that in a little bit. So let's talk a little bit about neurocognitive testing. So I know most all of you here are very familiar with neurocognitive tests. Many of you use them in your research and clinical practice. So I'm not going to spend too much time talking about their specifics, but there are a few important points I want to make that are important to the talk. So neurocognitive tests are a cornerstone tool, if not the cornerstone tool, to measure cognitive abilities in individuals across the lifespan. We use them to diagnose a range of problems like neurodevelopmental delays in children, neurocognitive impairment in adults, and dementia in older adults. And we use them to understand how disease affects the central nervous system and the brain's functional abilities. We use tests in conjunction with imaging, genetic and blood tests to understand the biological and behavioral underpinnings of disease. So they're very important to a lot of the work that we do. And I know you all know that. So, and typically neurocognitive tests are used to assess a range of abilities, such as encoding information, retrieval of stored information, ability to store and manipulate information over brief periods of time, our ability to attend to the most pertinent stimuli and problem solving and task shifting and so on. Now, there are some key prerequisites to using neurocognitive tests. First, they must be psychometrically valid. So there must be evidence that the test can measure what it purports to measure and that it can detect differences likely due to disease or other factors that are being studied. Second, tests have to be administered, scored, and interpreted by trained personnel. Whether a psychologist or neuropsychologist or highly trained psychometrist or research assistant, traditional tests require specialized knowledge to use. There's different starting points, basals, skip patterns, nuanced scoring. They involve a lot of resources and training to do them. Third, we need appropriate norms to confer a diagnosis, which typically requires a determination, right, to be made that performance on a test or across a battery of tests or in a domain falls within a certain distance from the normative standard, like 1 or 2 standard deviations below the mean or above the mean. And we'll talk a little bit more about norms, but inappropriate norms can lead to a misdiagnosis. And many normative samples from many of the commonly used tests are normed on very homogeneous samples and often just white people from North America. Finally, traditional tests require time. A comprehensive neuropsychological battery can range from 2 to 8 hours. It's quite a commitment to undergo such a long evaluation. So in short, neurocognitive testing is quite resource intensive. Now, ideally, these requirements will help the test overcome any biases that may be there so that the result you get is a reflection of the individual's true ability. But that often doesn't happen. I want to talk a little bit about some bias in our measurement tools. So unfortunately, neurocognitive tests have a history of being biased and even used in discriminatory ways. It's common to see different racial and ethnic groups perform differently, often worse than white populations on these tests, which has led some people to claim that IQ is race-based, like the authors of the bell curve. However, historically, many neurocognitive tests were developed in Eurocentric ways and normed on white populations, biasing them against racial and ethnic minorities with non-Eurocentric upbringings. In fact, the original norms of the very famous Wechsler tests, that's one of the most famous and widely used IQ tests, were done on all white people, and it was acknowledged as such. So some examples throughout our history about some of these biases. In 1979, there was a landmark court ruling where the California public education system was sued because of the practice of using IQ tests, specifically the Wechsler test, to determine which children went to special education classes. Many Black children at the time were being labeled as mentally retarded and sent to special education classes because of their performance on the IQ test. And around that time, 27% of students who were labeled mentally retarded were Black, despite Black students only making up less than 9% of the student population. So Black psychologists were arguing that the IQ tests were culturally biased, that they were Eurocentric, and questions like who wrote Romeo and Juliet did not measure a person's innate abilities. So a federal US district judge agreed, calling the test racially and culturally biased and discriminatory. And he ordered a permanent ban on IQ testing for special education classes across California. It's actually been just over 40 years since that case. And despite that, California is the only state that doesn't use IQ tests to determine special education status. And many people still think there's a bias there. A more recent example is cognitive testing in the NFL. So neurocognitive tests are commonly used to assess NFL players because they have much higher rates of dementia than the general population from all the concussions that they get. And a few years ago, it was identified that tests used to diagnose concussions in the NFL players were biased such that Black players had a harder time getting a dementia diagnosis than white players. And that made them lose access to all kinds of NFL services and payouts. Let me go back there. So the race correct, what they were doing was they were making a race correction. Because we have this history showing that different groups perform differently, we make a race correction. And that race correction was actually raising the bar for these Black players to get diagnosed with dementia. So instead of updating the norms to reflect the NFL population, and actually John's in here, somebody here has been working on that, or using less Eurocentric bias tests, they use this race correction. And that was litigated in court, and they've been trying to correct that since. So, and I also want to point out that these problems are not unique to neurocognitive tests as well, actually. And during COVID, we saw some really interesting findings come out where some of our tools, like the pulse oximeters that measure the oxygen level in our blood, and during COVID, we saw a lot of that. They were used to determine who was going to get the respirator or not. Turns out they were calibrated on white skin, light skin, and they're not as good as detecting oxygen level in people with darker skin. It's a bias in that tool that led to many Black people not getting the care that they needed. And it wasn't just pulse oximeters. Some of the forehead thermometers also do not work as well on people with dark skin. So unchecked, these biases in our tools lead to serious consequences: misdiagnosis, missed opportunity for treatment, and poor health outcomes. Anecdotally, when I came here and first got to go to South Africa as a postdoctoral fellow, I connected with some neuropsychology colleagues there, and I got to observe a neuropsychological assessment with a child. I think she was about 10 or 11 years old, from an NIH-funded fetal alcohol syndrome study. There's a lot of fetal alcohol syndrome in the Cape Town area with all the vineyards. In that study, they used the children's memory scales. They had forward and translated into Xhosa and Afrikaans, which are along with English, are the 3 languages that are widely spoken in that region of South Africa. But they didn't adapt the content. As my colleague read one of the stories to the child in the story memory subtest, where the child hears the story and then has to repeat it back, I was shocked. The story was about Native Americans and bison. I thought, surely this child knows little about American history, and why would she? So I asked my colleagues how kids did on that test, and my colleague said, well, they don't do very well, as you know, the content isn't really salient to them. You know, I don't know why they were giving that test, continuing to give that test despite that knowledge. So it's really important for us to understand how our tools have been developed and what their weaknesses are. Doing so will allow for better care and for better science. So now I'm going to give you a little brief cognitive test. So what animal is this? Anybody want to volunteer? Huh? Beaver, that's right. So this is a classic item from the Boston naming test, which is a very traditional neuropsychological test for aphasia or word finding difficulties. And it's been given all around the world. Now, do you think South Africans or someone from Southeast Asia would know what a beaver is? There's a good chance they wouldn't, because beavers are a unique animal to North America. And actually, the name of the test, the Boston naming test, says it all. It's from Boston, developed in Boston for Bostonians. So we all know, you know, Davy Crockett's beaver hat and all that. Now, anyone know what animal this is? What? What's that? Wildebeest. Well, what? No, that is an oryx or a gemspot. Now, if any of you said antelope, you would have been close, but that would be like calling a beaver a rodent. So if it were a naming test, you don't get credit for that one. Okay, one more. Oh, tapir. I heard a tapir. That's very good. So again, this is an animal common to Central America and like Malaysia. And the Bronx Zoo. Oh, there you go. Oh, yeah, that's a good point. So imagine being tested and encountering a naming test that was developed in Malaysia or somewhere not here. You might see some animals or objects that you're not familiar with. And if you got those wrong, does that mean you're impaired, cognitively impaired? Or does it mean that the test was biased? It doesn't reflect where you came from. So what does this mean globally? Well, first, I want to highlight that there's a great need for testing globally. There are tens millions upon millions of people who experiences diseases and disorders that affect the brain and nervous system that could probably benefit from testing. And in many settings, neurocognitive testing may be the best method to detect some of these problems because those settings don't have access to imaging or other fancy genetic or blood tests that can detect some of these problems. Now, you can see there's just briefly, over 315 million children that experience diseases that can contribute to neurodevelopmental delays or disabilities. There are 55 million people living with dementia globally. There's 21 million new cases of TBI, traumatic brain injuries globally, 40 people living with HIV, 40 million people living with HIV globally. And in this one study, they said about 3.4 billion individuals have a condition affecting the nervous system. So I have a little asterisk next to HIV because most of my work has been with youth and adults living with HIV. As some of you may or may not know, HIV affects the central nervous system in the brain, and rates of cognitive impairment in people living with HIV can range from 20 to 50%, even among those who are treated medically, or what we'd call virally suppressed. Furthermore, with greater access to better medications, people with HIV are living longer and are at high risk for developing dementia, often at earlier ages than the general population. And because neurocognitive impairment is very prevalent in this population, the US National HIV Curriculum actually recommends that persons with HIV should ideally have a baseline neurocognitive assessment with follow-up screening every 6 to 12 months for high-risk individuals and every year to 2 years for lower-risk individuals. So if you think about 40 million people living worldwide with HIV, 20 to 50% of them have cognitive problems, impairments, although most mild. But I'm not going to get too much into that. So now I want to take a moment to talk about the global south, because you saw that slide with the millions and millions of people with all these brain-involving problems. Well, the majority of those people live in the global south. In fact, it's about 84% of the world's population live in low and middle income countries. So they're the ones who are suffering the most from all of these brain-involving disorders. And they come from settings that are very diverse culturally, diverse linguistically, medically. And as you can see here, 700 million of people live in extreme poverty. That's less than $2.15 a day. 3.5 billion people live on less than $6.85 a day. So these are people growing up in very different environments than we're used to. There's limited resources for food, healthcare, education, and so on. And the map there shows you generally where the global south is, the countries, most of the world. So let's talk a little bit about doing some testing in these settings. So some of the issues for neurocognitive testing reflect some of these disadvantages. So a study we did some years ago in South Africa, back when I was a postdoc here, found that many items on the Montreal Cognitive Assessment, a very popular screening test for mild cognitive impairment, may not be appropriate for certain populations in South Africa. So in this study, we had 39 HIV positive adults and 39 demographically matched HIV South African adults. They're on average 29 years old with 11 years of education. So they completed the MOCA, and we saw the expected differences that people with HIV performed overall worse than people without HIV. But there were some really important caveats. For example, cube drawing. Most participants could not correctly draw a cube, and most could not correctly identify a picture of a rhinoceros. HIV status didn't matter. So it's really important to note that the communities from which these participants were recruited are these impoverished informal townships that they're all over South Africa, they're all over Cape Town. This is what they look like. They're shanty towns. These are older pictures. There has been government activity to give them more permanent housing structures. And given the age range of these people and when this study was done, because this is a little bit older, all of these participants were educated during apartheid. So I'm sure everyone here knows about apartheid. And what that meant is, as a Black person in South Africa, despite being the majority population, you were relegated to the worst living conditions and the worst education. So you didn't have educational advancement. Higher education was very rare for Black people and even people with darker skin. So they are forced to live in these resource-poor settings, limiting their exposure to all kinds of enriching activities, while increasing their exposure to food and financial insecurity, unemployment, and poor health. So, and you can think about it. Here, our kids, from an early age, you're doing mazes and all these activities. I mean, I know in elementary school, I'd be drawing in the margins of my notebook, doodling and drawing cubes all the time. So you have that experience. So that they couldn't draw a cube is not really a reflection so much of cognitive issues, is that they just have never done it before and they haven't had that practice. Similarly, if you think about these animals, even though if we go back to the mocha, the three animals on this version, the lion, the rhinoceros, and the camel, those are indigenous animals to the African continent. And the lion and rhinoceros are indigenous to South Africa, the camel is Northern Africa. It's not like these are these community members are the ones going to the safaris and going to the game parks and really getting a lot of access to seeing these animals. So with these floor effects, amongst the HIV negative participants, we saw that their performance on these different items were the most consistent with the MoCA norms from the Alzheimer's group. These are people 60 and over from North America. So you can see here, actually I should use this. So you look at the row with the cube, their mean performance is most consistent with Alzheimer's patients. Similar, the same with the naming task, same with the digit span, same with serial sevens and the abstraction, which is how are a watch, I can't remember the other one, it's on there. A watch and a ruler alike. And on the orientation task, they actually perform most similarly to the mild cognitive impairment group. So what does that mean? I don't think these people without HIV had dementia, because they were living their lives and doing things and didn't show those, gross signs of aphasia and stuff like that. But they just didn't perform very well on this test. So to further understand this, we conducted semi-structured interviews with 22 participants, 15 living with HIV and 7 without HIV, of similar ages and gender, who had recently completed a battery of neurocognitive tests for a research study. We wanted to understand what their familiarity with these tests were and what their experience completing them was. So all 22 had never done any tests like this before. When asked about their overall experience taking the tests, we had responses like this: it's difficult to do something accurately when it's your first time doing it. Therefore, it would be better if you showed me or led me. And some of us know sometimes you get a practice trial on these tests, but you don't really get instruction on how to do them. You get a very brief introduction, you maybe get to try it, and then you're thrown into it. When asked about specific tests, such as ones that require drawing, we had responses like, well, drawing is unable to do.
I helped her with her bedpan and all, and then I was in the way, right? She said,
the voice of God. We had responses like, well, drawing is something I was unable to do. I hardly ever do it, and I've never even draw for that matter. There's among time tests, any of those you've given tests, you have a stopwatch, the person doesn't know what the time limit is, you just say go, and then at some point, maybe 2 minutes, a minute, you just say stop. So we asked them what that experience was like. They said, it makes me think I must be stupid not to finish the task within the time limit, even though they may get some initial instruction that not everybody finishes all the test items. They just don't have that experience with it. So it creates that anxiety. And, get my mouse back here. So we know from studies like on stereotype threat, when people feel anxious about their test performance because they're made aware that people like them don't perform well on these tests, they don't perform as well as they could. most people experience some level of test anxiety, which is normal. But it becomes problematic when that anxiety is really interfering with their performance. Like for someone totally unfamiliar with testing, who's been subject to systemic bias and racism and told they're not smart. So you can see there's a lot of challenges to doing this kind of testing in low and middle income countries. South Africa is a unique place with apartheid. Not every country has gone through that kind of systematic, institutionalized racism to that level. So we need to make sure that items are appropriate, the test instructions are understandable, and need to consider an individual's experience and comfort taking these tests. So finally, many low and middle income countries have very limited healthcare resources and personnel, especially mental health care providers, which includes psychologists and neuropsychologists. These are data from the WHO mental health workforce. Some of you probably are familiar with this. And I've just highlighted some of the low and middle income countries where I've worked or collaborated. And you can see that there's just very few of these trained experts who would be the first line of people, at least here in the US, who would be administering these tests. I mean, you take Uganda, that's 0.04 psychologists per 100,000. Now you can compare that to the US, which is 29. France has 49, Norway has 48. So France and Norway are way ahead of us. But it's really dramatic to see that there's so few providers. And actually, these data can be a little sparse. You can see that sometimes you can't find data on psychologists, but they have data on psychiatrists. So I use that as a proxy. So to address this overwhelming paucity of healthcare personnel in the low and middle income countries, many countries have employed task shifting strategies where community health or lay workers take on certain healthcare tasks that do not require medical or advanced degrees. In the case of HIV, a lot of lay counselors will do HIV testing and counseling in South Africa. But it's not clear if traditional neurocognitive tests or even screening tests can benefit from task shifting. So we decided to look at that. In another study we did in South Africa, we wanted to see how lay counselors fared at administering a screening test for HIV-associated dementia, the International HIV Dementia Scale, which I believe is in the US National HIV curriculum. So lay counselors were trained to administer this test. It's pretty brief, 5-10 minutes. It's got a 4-word recall memory task, finger tapping. Just do this as fast as you can in like 10 seconds. And it also has the fist edge palm test, which would be fist edge palm. It's a motor sequencing or psychomotor programming task. So if you get a score of less than 10, then that indicates that you probably have or are likely to have HIV-associated dementia. So using the scores from the lay counselor administrations, we found that 80% of the sample screened positive for HIV-associated dementia, which is unusually high for people living with HIV who are on treatment. In fact, rates of HIV-associated dementia range more like 2 to 5%, 5% at the most in most studies of treated people. Now, this particular sample were people who were struggling with medication adherence, so it's possible. But a leading explanation for this is that the lay counselors had a hard time really judging and scoring the motor tests. And there we go. Specifically, the fist edge palm test, which I don't know if anyone ever here has done that. It's actually not that easy. And it's not clear, was that right? Was that wrong? Should I count that? Should I not count that? And that was the lowest score amongst all the scores. So, I suspect that they just had a really hard time judging that. So in some, task shifting strategies may not be appropriate for some of our traditional neurocognitive screening tests. So where does that lead us? Well, to address these neurocognitive testing issues in low and middle income countries and the shortcomings of traditional tests, I began to wonder if technology could help. And along with some colleagues, we developed this app called NeuroScreen. And at the time, we chose the tests, that we thought would be least affected by culture. So in fact, the idea for the app was born when I was on an extended stay in South Africa. We had completed a recent pilot study, the one with the MOCA, and my colleagues and I wondered if there was a way to make testing, in particular screening, more feasible in the busy clinic setting and amenable to task shifting. So at the time, I had no idea. I thought it was a great idea, and I had no idea what went into developing an app. So I just started asking anyone I knew if they knew any software developers or programmers. And actually, one of our project managers at the time for this, for Bob's study, I was meeting with her and talking, and she mentioned that her husband was a software engineer. And I said, really? Really? Can I talk to him? She's like, well, about what? And I'm like, well, we have this idea. And she's like, well, let me run it by him. Well, a couple of days later, we met, and he was really interested in it. Actually, he thought it was a great idea because he thought he could give something back to South Africa. And then he brought another friend in, and the rest is history. So NeuroScreen is an Android operating system app, and actually we chose Android. That was on I call it developers' advice, because Android is much more prevalent or ubiquitous in low and middle income countries. It's cheaper, devices are cheaper, and more people have Android in low and middle income countries. So that's why we chose that platform. So it's a highly automated app. It's very easy to administer by non-experts. It's brief. The current set of tests, or the core set of tests, takes about 25 minutes on average to complete. And we assess learning, memory, processing speed, working memory, executive functioning. It has audio video instructions, which are really good for low literacy populations. It works on and offline. When it's online, all the data gets synced to a server. And we've spent a lot of time to reduce as much bias and make it understandable and acceptable as possible. So, currently we have these 12 core tests that we've been using in our analyzing, but in actuality, the technology we record thousands of data points, which I'm hoping at some point when I have the time and can analyze my data, that we can identify novel components of test performance, such as patterns of errors, reaction times, neurocognitive phenotypes, and such. There's just a lot of data that comes out of this. And actually, with all the data, we have common data elements across the NeuroScreen battery for cross-country, cross-site comparisons. It's all the same variables. So these are just some screenshots of what the tests look like. These are traditional, really it's some of the traditional test paradigms put onto digital. And there are other apps out there. There's the NIH Toolbox and such, and they're sort of use these classic test paradigms. For our app, 2 of the tests, the verbal learning and the number span, are staff administered. And then the rest essentially are self-administered with the staff person right there to address any kind of issue. And it's really easy to use. And you can configure which tests you want to use and administer them in whatever order you want. The video instructions, as I mentioned, they're totally standardized. So you get reliable administrations. And given that we know about these issues with bias in our tests, we go to great lengths to ensure that our tests in our different settings are understandable, valid, and easy to administer. We have a rigorous translation process, which is based off of work by Brislin. We call it a group consensus. We do a forward translation, a blinded back translation. We do a group review of the discrepancies. We incorporate feedback from target groups who will have ideas about how to use different words. And this can be challenging. This is actually a screenshot from work we've done in Uganda, where we were adapting the app for Luganda. And you encounter really interesting things, and you need input from multiple people to understand that even though the word circle, there's a Luganda word for circle that's in the Luganda dictionary, very few people know that word. And in fact, the best word to use would be isako, which is an Anglified version of circle. But that's the word people know. But it takes, you do the forward translation. The translator's like, oh, okay, they put in the dictionary word, and then you come back to your group and they're like, they have to go look up that word and say, oh, that is circle, but people don't really know that. So we're aiming to have language that's very accessible to, the largest portion of the population. But it takes that process to really get there. In our acceptability, understandability, and usability evaluations, we incorporated an adapted cognitive interviewing methodology. And for those of you who don't know, cognitive interviewing is a qualitative research method used to improve the design of survey questions and ensure they're understood as intended by the target population. And that involves in-depth, semi-structured interviews with individuals to explore how they interpret and respond to survey items. So the goal there is to identify and fix issues with question wording, structure, and format that could lead to misunderstanding or bias. Now, I want to make it clear, neurocognitive tests are not survey items. They involve instruction sets and stimuli that a person has to interact with. So we had to do some adaptation here to figure out how we can use that kind of methodology to look for those kinds of errors. And that's in how instructions work, and if the stimuli are appropriate, and so on. So in our protocol, this is a video of one of our cognitive interviews. This is a video, it's sped up because these are very long and time intensive, but I just wanted to give a flavor of it. We'll videotape people and we present participants with a test from the app. We have them take the tests and then ask them a series of questions or probes about their experience using taking the test, such as, did the instructions make sense to you? How did you decide to do this or that? Were the stimuli acceptable to you? How was using the tablet to complete the tests? And when participants make errors during a test, we might stop them and ask them about what happened to better understand if they didn't understand the instructions or what, if it was an issue with the test versus an issue with their brain. In our protocols, we videotape the participants and we'll do follow-up where we'll put the test on a laminate and then have them go through it and explain the instructions to us so that we can sort of find any really major problems with their things, and actually some subtle problems. So this guides how we develop new tests and make modifications for certain aspects of the tests that don't work well. So we're currently writing up this protocol and hope that it can push the field forward to develop more understandable, acceptable, and less biased tests. So since the initial development of Neuroscreen, we've been able to adapt it for a number of different languages and populations and look at the psychometrics of it. In one of our early studies in South Africa, we adapted Neuroscreen for language, for the Xhosa language, and compared performance on lay counselor-administered Neuroscreen to a psychometrist-administered and supervised gold standard neurocognitive test battery to see how well it could detect neurocognitive impairment as defined by that gold standard battery. This was done in Cape Town in a provincial, like a government-run medical clinic serving everybody, but this was part of this one of Bob's add-on to Bob's study. You can see here, the mean age is about 33, predominantly female, which really reflects some of the HIV epidemic there. Most participants had about 11 years of education. Most of the participants were virally suppressed, like medically controlled with their HIV. This is the gold standard battery we gave them, and it's a battery that researchers in HIV had been using in South Africa for a number of years. It's actually a battery that's been used here in the US quite a bit. So very comprehensive. I think it took about two to 3 hours, depending on the person. We calculated global deficit scores, which is, I'm not going to get into that, but it's a popular method for looking at impairment. And if you have a global deficit score of 0.5 or greater, that's an indication of impairment. And then we converted all the Neuroscreen scores to sample-based Z-scores for each test, and then created a global Z-score, which is the average of all 12 Z-scores. So here, we found that the gold standard battery indicated that 26.5% of the sample met that criteria for neurocognitive impairment. So we did sensitivity and specificity analysis of age, education, and sex-adjusted neuroscreen scores, those Z-scores. And using the global Z-score with all 12 tests, we saw that the app had a 82% sensitivity and 75% specificity to detect neurocognitive impairment, as defined by the gold standard battery. Then we wanted to, and that takes about 25 minutes on average to complete. So we just wanted to play around. Well, what if we put together a battery that only took 10 minutes? So we took out 4 tests that would take about 10 minutes. And with those 4 tests, we saw that the app had 92% sensitivity and about 71% specificity to detect that cognitive impairment as defined by that gold standard battery. So the idea here is, well, something like this, it's easy to use. We had lay counselors administer this with just a couple hours of training, and you're getting results that are very close to the gold standard multi-hour battery. We did another study with those data, and this I won't get too much into, but here we looked at tried to address issues of bias and factor structure, and this is more construct validity of the processing speed tests in the app. And here we found that all the processing speed tests loaded onto one factor, and using norms generated from a sample of demographically matched HIV negative community participants, we found that using those norms, we saw that same HIV difference that we expect, the HIV patients performing worse on those tests. Another somewhat recent, I guess it's been 4 years now since Thailand, we got a grant to adapt Neuroscreen for Thai youth and young adults living with perinatally acquired HIV. So we did a whole language translation from English into Thai. We had focus groups of adolescents and young adults to evaluate the app for understandability, acceptability, and usability. Then we administered the app to 50 youth with HIV and 50 without HIV. And they also completed a gold standard neuropsych test battery. Then we looked at correlations, mean differences, proportions. This is the full battery that they got, a lot of different tests. This was actually nested with a larger longitudinal study of neurocognitive outcomes in perinatally acquired HIV. The resilience study, anybody knows that. This is our correlation matrix comparing the Neuroscreen scores, I believe. Yeah, they're along the top, and then the other tests are on the left side on the column. That's a lot to take in, I know. Whoops, where is my, there we go. I just highlight some of the main correlations between the most conceptually similar tests. So we're comparing these tests, that some of them, they're not the exact same tests, so we don't expect perfect correlations, but some of them are conceptually similar, like a trail making test where you're connecting the circles in order. With a pencil, well, we do that on the tablet screen with your finger. And you can see we had very high correlations across most of the tests. The motor speed tests weren't as highly correlated, but overall, these very strong correlations. When we compared the global scores between the Neuroscreen battery and the full battery, we had a correlation of 0.82. And across all those, we have small to large correlations. And we saw mean test performance differences between the youth with HIV and those without. And we saw those differences were similar between the Neuroscreen and the full battery. And both sets of tests identified similar rates of impaired participants. So moving on to a smaller study we did here with Claude Mellons and the CASA cohort. And this is all pre-pause. And it's important to note, though, that resources and access to neurocognitive testing can be challenging here in the United States as well. So I've highlighted the issues in low and middle income countries, but actually we have those same issues here. And through the AIDS education and training program here that Fran is part of, I do these trainings on the neurocognitive aspects of HIV. And it always comes up, people, these are social workers, these are community clinics. And people are like, well, where do I get my, where can I refer for neurocognitive testing? And it's a very hard question to answer. Or if they do have access to a neuropsychologist, they say, oh yeah, we do. And we make those referrals and the wait time is 1 year. So we have our own issues here about access to doing this kind of testing. So we looked at it with young adults, adolescents, I guess 18 to 30, young adults, adolescents, young adults with perinatally acquired HIV and those exposed to HIV but uninfected. That's born to HIV positive mothers, but they weren't born with HIV themselves. And we compared their performance on the app to some traditional gold standard tests that were part of the CASA cohort battery, which is also another longitudinal study that's been going on for about 20 years now, following these people through childhood up now until they're about 40. Great. The median age of participants was 24, 60% male, most, well, all of them really from the inner city, 46% Latinx, 44% African-American, mean years of education 13. So we see, again, the medium to large and statistically significant correlations between the neuroscreen and the traditional tests of processing speed, working memory. So the tests that were in that were trail making, A and B, and digit span forward and backwards. That's what was part of the CASA battery. So we used this on a small number of participants to see it there. So so the results provide support here that there's psychometric validity of a neuroscreen app in this population. And in the latest iteration of CASA, we've moved exclusively to using neuroscreen. So finally, this is data from a recently completed study where we examined psychometrics of the app in Uganda. So I showed that the screenshot of our language translators and our group consensus folks. We adapted the app for Luganda and then administered it to 50 adolescents with perinatally acquired HIV and 50 without. And then they completed a battery of 11 traditional tests. We did Pearson correlation coefficients between overall performance, global Z-score on the app and the traditional battery. Let's see here. This just shows the participants, the demographics, nothing really to highlight here other than you look at the monthly income we have of these folks, it's very low. I thought I had a note in here. You can see the exchange rate down there. $1 is about 3,700 Ugandan shillings. So if you do the math, that's not much money. I can't do that math in my head right now. I had done it earlier on a calculator, but I can't remember it. I thought I put it in here, but I didn't. I think it was around $10 or $12, something like that, or maybe $40. Anyway, the point is really low. These are not resource-rich communities. So this is the test, the list of tests that we gave from the paper and pencil tests. And then this just shows the correlation matrix. These are unpublished data and data that were analyzed pre-restriction time. So we haven't been able to get back to it, but the correlation between the global scores were large, 0.73 between both batteries. And again, the group with HIV had lower mean Z-scores on all but 2 of the motor tests than the control group, and significantly worse Z-scores on tests of processing speed, executive functioning, learning, and memory. And the global Z-score for the positive group was significantly lower than the HUU group, the control group. So many of you may be wondering what technology use and access is like in some of these settings that I've mentioned. It's not like everybody has a tablet or a computer coming from some of these communities. So here's some analysis we did a couple of years back across several different studies. On the left, this is a study we did here in New York. I didn't present that one, with adults living with HIV. And this is the South Africa study that I presented earlier with those 102 adults living with HIV. And you can just see, I have to look down here. we have ever used a computer, smartphone, and tablet. And you can see pretty high here in the US, very different in South Africa. Much more people using smartphones than computers or tablets. And then we ask about ownership. Do you own a computer, smartphone, or tablet? Again, much higher in the US than in South Africa, and with computers and tablets being way lower than smartphone use. Smartphones are very popular and affordable compared to tablets and computers. So then we asked them, well, how easy or not was it for you to use the NeuroScreen, to do the tests on the tablet? And you can see that even despite those differences in technology use and ownership, it's fairly consistent. Most people are reporting that it was easy to take the tests on there. Then we also asked them about which tests were the easiest to do. Over here, we have a comparison between adolescents with HIV. Actually, HIV, yeah, these are mixed, so it's HIV and controls in Cape Town, as well as from Kampala. So these are the same participants who were in the study I just presented, but you only see 80 because of data analysis restriction issues. But anyway, again, you can see that South Africa, the youth have a lot more exposure to technology than those from Kampala. Again, smartphones are the most widely used. Comfort using a computer or smartphone, you can see that. Pretty consistent in South Africa, much lower for computers and kids in Kampala. But again, most people are reporting that they found it pretty easy to use the tablet. And again, we show some, which was the easiest. So since all that initial work, I've had a lot of interest from people around the world say, we need some tests. So people have come to me and we've developed a whole bunch of different versions of NeuroScreen for different languages and going through those processes. So in conclusion, NeuroScreen is a psychometrically valid battery of tests, neurocognitive tests, across numerous settings, cultures, and countries. Our rigorous adaptation of NeuroScreen has made it highly acceptable and understandable to many different populations across the globe and in low and middle income countries. It's easy to use, it can be used by lay workers, and it's shorter than a traditional neurocognitive test battery, yet provides similar results to that traditional battery. Tools like NeuroScreen have great potential to make neurocognitive testing more accessible, accurate, fair for global populations. And now here's a random bullet point. I don't know what that is. So future research that I know I would like to do, continue to adapt and evaluate NeuroScreen for use with other populations and other low and middle income countries, like older adults, to look at to assess for dementia, use this tool to examine causes and mechanisms of neurocognitive impairment in low and middle income countries, developing global norms. One of the sort of drawbacks right now, we don't have an extensive pool of norms for NeuroScreen, which makes its clinical use a little less problematic, a little challenging, because we don't have those norms. Some of the current projects we have, aging adults with HIV, where we've adapted a NeuroScreen for Bahasa Malay, Tamil, and Mandarin, which are 3 common languages there, and we're testing it out there. Adolescents with HIV in South Africa, that grant is almost over. Also, I didn't talk about, we've been trying to see how it works with young children in Uganda. And then our newest grant in Uganda is with, that should be 5 to 12. That should be 15 to 25. We're looking at actually using the app to understand factors affecting neurocognition in those populations. So I know I'm a little bit over time. So I just want to acknowledge that all of this work couldn't be done without the thousands of participants who've been in our studies around the world, all of my colleagues here at Columbia and NISP, colleagues in South Africa, Malaysia, Thailand, Uganda. There's actually should be another group from New York. And of course, I want to thank all those collaborators and all our funders at NIH.
Thank you.